Good afternoon and welcome to this session for Red Hat Storage Server, where we'll be discussing the use cases, providing you a product update, and the roadmap for Red Hat Tech Exchange. So my name is Sayan Saha. I run product management for Red Hat Storage Server based out of Westford in the United States. I actually came to Singapore to record this session along with another one tomorrow. And thanks for joining, and hopefully you'll learn something and it will be useful for you. So without much further ado, I'll look at the agenda. Um, so we'll go through some real life use cases. We will start this preso with actually describing how customers are using Red Hat Storage. Now, Red Hat Storage um, has been released or has been available as a product from Red Hat for about 2 years now. We launched the product in June of 2012, so it's not full 2 years, but close. And we have learned a lot in this time, and we have also seen how customers are using it. So we'll go through three case studies of showing how customers are actually using it today, which will also delineate the use cases, to some extent. Then we'll look at what is the roadmap strategy for Red Hat Storage Server. Now it's clear that you know, we could do potentially a lot of things with this piece of technology because it's pretty cool. And there's a lot of things that we could do with, but we need to focus on a few things that actually help expand the business for Red Hat Storage Server. And so we have come up with a strategy that will be the overall guiding principle for our roadmaps going forward. So I'm going to spend some time on that. Then I'll go through a brief technical overview of GlusterFS, which is the underlying file system on which Red Hat Storage Server is based. Then I'll discuss the upstream roadmap for Red Hat Storage Server or GlusterFS projects roadmap. Then we'll go downstream and see what's expected, from on the product side in the next 6 to 9 months. Then we will discuss the applicability of Red Hat storage for big data use cases. Then I have a video clip with me where we will provide a demonstration for the upcoming snapshot feature, which is expected to debut in Red Hat Storage, 3.0, and then we'll summarize the session and end it there. So we start with an interesting use case, which I call, file store for big data analytics, which is, the way it started was it's a leading automobile manufacturer based actually here in Asia, wanted to store sensor data from their next generation cars that they're making. These cars or autos, they don't tell us what exactly these cars what the next generation technology is, but we suspect these are driverless cars and these have lots of sensors, and these sensors, as you expect, generate a lot of data. And they needed a reliable file store for storing it, and not just storing the data, but also expanding at it, and pay as you grow as you go, so that they can seamlessly add more storage to their storage pool as and when needed, as opposed to sort of me adding a new storage service or migrating from an existing storage service to a new one when they hit the wall with their existing storage service. The data that is stored in this cluster would be used to is stored in this cluster to would be used for analysis. So they would run analytics on this. It can also be used for audit and other reasons. We don't know all the usages of it, but basically that was the reason. So the data growth is expected to be up to 200 terabytes per week, and they're looking initially at a 5 petabyte total capacity of data store. Their pain points were, they wanted to rapidly scale on demand. So they really were not looking at a solution which was traditional scale up storage where, after 500 terabytes, you hit capacity and then you go buy a new storage system. And they're also planning to do the scale up, and the scale out in a cost effective manner, which was also very key in their decision-making process. So the solution and outcome was they selected Red Hat Storage Server to scale cost-effectively with demand, and they are actually using SMB, Windows-based clients, and the native client for rapid data ingest. Let's look at a second use case in a content store for video production. Um, we have, this is a company based out of North America, actually in the United States. What they do is they are a video production as a service provider. It's almost a small version of YouTube for enterprises. What enterprises do is they go to this company when they want to create videos, render videos, and then serve them out, using their portal. They go to this production house, and they basically the use case here is just ingest video from multiple sources, transcode the video in 9 different formats, and then distribute to its client. That's kind of what they need it for, and they need a storage platform in the heart of it all. This whole workflow, which is ingestion, transcoding, and distribution. They wanted a storage platform in the heart of it all. They actually were using GlusterFS upstream, already, but basically the storage platform had become very critical for their business process. So they could not simply keep using the upstream version or the community version of GlusterFS. So they came to us and said, we need a commercially supported version, and then adopted Red Hat Storage. So the end result is they adopted Red Hat Storage Server to provide a cloud-based video platform that enables media processing, distribution, and IP streaming. Let's look at a third use case. This is very interesting too. This is about a public transportation provider based in Europe. They needed a file store for storing data that was coming out of the sensors um, in the subway line that the trains monitor. So the trains monitor a set of sensors which make sure the lines are clear, etc. And they needed a storage to store all of that sensor data. And they also needed a replicated copy of the data in a nearby data center. So in case something happened to the current data center, the trains can still monitor the data that's coming out of the subway lines. Their pain points were they were using an end-of-life, proprietary cluster file system, and had frequent outages, and were not able to get good support for it because it was end of life. This particular solution did not have very good replication capabilities, so their nearby data center, the data center that they had nearby, was not able to keep up with the primary data center. And the other requirement they had was they already had hardware, and they wanted to repurpose that for running storage serving, basically doing storage serving. So they didn't want to go buy a whole set of a brand new set of hardware, storage hardware or server hardware, for doing any of this. They were on a budget, and they wanted to use commodity hardware that they had lying around. So Red Hat Storage fit the bill. It provided stronger replication capabilities, a file store that can be expanded at will, and could use the hardware they had lying around, and they did not really have to go and repurpose or put in an order to buy new hardware. So they are using Red Hat Storage Server from both Windows and Linux boxes, and they are also in addition to running the monitor service, they are using it as a secondary document store, but that's not their primary usage. So these were the 3 case studies, that kind of showcase this solution and how our customers are using it. And these are mostly recent wins, so they're not like from 18 months back or something like that. All of these happened in the last 3 to 6 months, so to say. So they're all new wins, fresh. So let's spend some time on the next topic that we talked about is what's the strategy with Red Hat Storage? Where are we trying to take it? Clearly, when we bought Gluster in fall of 2011 in October, The biggest reason that why we bought Gluster was we realized that unstructured data was growing at an exponential pace, and enterprises were struggling to keep up with it, and they needed a solution for that. And we also realized that they were using not the right tool for the job at that point of time. That is trying to store unstructured data in SANs or expensive high-end storage equipment, and everybody was flying first class. In other words, all kinds of data were being kept in places where they probably did not need to go because they could probably go in some other kind of storage. So that reason hasn't gone away. 2 years down the line, or more than 2 years down the line, unstructured data growth remains exponential. Enterprises are still, struggling, and more than ever, there is a need. There's a need, or there's a need for a solution that addresses it. So this has become so popular, actually. This whole solution set, or whatever we want to call it, this domain, that we have got, IDC and the Gartners of the world come up with a new acronym for this industry, which they're calling, software defined storage. And that's primarily, being used, basically, to designate solutions that are software based storage solutions that ships the software only, and you can put it on any kind of commodity hardware, and run them together, as opposed to the traditional storage business model or go to market, which always includes appliances, where when you order an appliance, you actually get a storage appliance that you plug it in, and it starts working. So this industry is being turned on its head. The storage industry in general, by this new concept, and some of these new workloads are driving that change. One of them being, unstructured data. So what we decided to spend time this year, at least, was making sure that Red Hat Storage was capable of doing these three things. Now, create the best open software-defined storage for file serving, create the best storage provider for LOSP, and we still want to do, we want to continue to do foundational work for big data storage, which we think is another workload that's going to drive storage needs for the next for the next in the next 5 to 7 years. Now, most of you know in this call that after the Inktank acquisition happened, which by which we got the Ceph property, we are not emphasizing Red Hat storage to be sold in Ceph use cases. Sorry, in OpenStack use cases. So we are targeting Ceph for those, but the top one and the bottom one, still are relevant. They belong to Red Hat storage, and all of the things that we do in the roadmap in the next 18 to 24 months will be, because of these two reasons, for Red Hat storage. That is, to create the best open software defined storage for file serving, and to support big data workloads. The other thing that we have also noticed that, in our journey with Red Hat storage, that it's a very difficult fight if you try to go to an end customer and tell them that we can match feature by feature what traditional storage providers give in their equipment. So we knew this, but it has become clearer in the last 2 years or so, that it's a no-win situation if you're going to tell people that we're going to offer feature by feature compatibility with your existing storage. The sales cycles are too long, and there is inevitably one feature that the traditional storage vendor provides that we don't, and then we get cut out. Instead, what we will be focusing more and more are workloads. So the way we look at it is, if we'll take workloads and we'll try to do everything that we can do for that workload, so we can kind of position our solution as default for those workloads. And we are seeing definitely an uptake on new kinds of workloads that are coming, which includes OpenStack and big data, which actually shifts the conversation from, okay, what features do you have, to what storage do I need for those workloads. So if we go to the next slide, this is kind of an attempt of what we're trying to do. Um, The content cloud is what we call file serving, and storage for big data analytics is for big data. Is we're trying to shift the conversation from feature functionality to what storage I need for a particular workload. Because if you look at how the storage industry has evolved over the years, storage companies that have been really successful, and are still successful today, have been always able to provide a solution for specific workloads, as opposed to doing every feature uh, that somebody can possibly think about. That usually doesn't work. But if you can do all the features for a known workload and position your solution with that, and do all of your marketing and all of your activity focused on that workload, that usually works well. So that's how we are going to kind of look at it going forward, as opposed to trying to tackle every use case or everything a customer can think of. We will do it workload by workload. So in this slide, you'll see some examples of work that we have already done. We have actually done a lot of work to make Red Hat storage a good, target for for own cloud, a backup target for own cloud. Backup target for Commvault. We have also worked with OwnCloud, which is a file sync and share service, to make Red Hat storage, a backend for OwnCloud. We are working with Splunk, which is a log analytics tool, to make Red Hat storage, a good candidate for cold storage for Splunk. And we have our traditional document and file store use cases, which have been our bread and butter use cases for the last 2 years or so. Same with big data analytics. We're basically looking at a whole bunch of workloads, which include log analytics and MapReduce, etc., to and do the features that we need to make this workloads run really well, as opposed to trying to target every feature that a traditional storage, hardware has today. So that will be, our approach going forward. We want to marry, our solution to a workload, as opposed to do feature function for the heck of doing it. Here's an example. In this slide, I take one of these new kind of emerging workloads that we are working on. This one, Splunk. Splunk, for who, people who are not familiar with Splunk, what Splunk is an analytics tool that is able to basically parse log files and find out if useful information for an user. So in this slide, what I show is, a Splunk, indexers running on, nodes. They also host the search heads, to which the users make query. So a whole bunch of data comes to these nodes, these pink nodes, and these data comes from different sources. It could come from IT systems, operators, admins, etc. They're usually coming at a really furious rate, and they're constantly getting indexed by the Splunk indexers. And in addition to having the indexers on this node, you also host search heads. So users asking, wanting to know certain things about, of what's going on, can query these nodes to find out what's going on. So Splunk has this concept of three kinds of storage for all these log files that are coming to it. It calls it hot bucket, warm bucket, and cold bucket. And what happens is, when data comes in, initially, it gets stored in the hot bucket. Then after some times, it goes into the warm bucket, and then after sometimes it goes to the cold bucket. So Splunk currently recommends using only local storage for hot bucket, because the performance they desire out of these hot buckets and warm buckets also is extreme, and no, they don't recommend any kind of storage, that is not local storage, for doing this. However, for cold storage, or cold bucket, it is possible to position Red Hat storage as an alternative, and this is what this shows. We're currently working on a white paper, with a partner that basically supplies her the hardware, and we are documenting this use case. So this is a good example of one of those emerging use cases where you don't really have to run up against okay, do you have deduplication, or do you have erasure coding, or do you have, LDAP authentication? But if you can do this really well, people wouldn't care. So this is an example of emerging use cases where we are trying to solve all the problems for this use case and position this in a way so that, yeah, customer just, it's just a no-brainer for an end user. So in this slide, I just really try to focus on something interesting that's happening in the hardware world as we speak. When we started the journey with Red Hat Storage in 2012, we had, software, open Red Hat Storage, and we basically recommended you can run them on compute servers that also run RHEL, so there was no differentiation really. Okay, if you have a Dell server or an IBM server or an HP or a Cisco server, you can just run Red Hat Storage instead of RHEL, and you can get, storage servers out of those. Fast forward 2 years, things have changed. We have seen vendors coming out with exclusive, storage servers, basically servers, x86 servers that are tuned and built for storage serving. Now, this has basically changed the game because now not only can you pitch your solution saying that, oh, it has all the goodness of being a software solution on community hardware. You can actually go with a partner and convince a customer, or actually pitch to a customer saying, not only do we have the open software, but it runs on a purpose built, hardware that's actually designed for doing storage serving. Now, this makes the story much more real than it is on, pick your server and we'll run on it. So that's really a clincher, and we are working with at least 2 or 3 partners on coming up with some reference architectures on servers that are being purpose built for storage serving. So, stay tuned for those. I think a couple of them have been already published, and others will be published. And not only are we going to publish Red Hat Storage Server on the servers, but we'll also have example workloads that you can run on them, so that the story is even more real. So we're looking at running, on cloud, Splunk, and a few other workloads on example hardware and from some of these vendors with Red Hat storage to make this story, gel really well. So let's quickly go through the technical overview. I know that some of you actually know about it because Gluster has been around, in the company for a few years now. So some of you must have seen the slides before. So I'll just quickly go through it, so that, if you haven't seen this before, or this is the first time you're listening to a Red Hat storage presentation, you can sort of, connect the dots. So Gluster has, or Red Hat storage has really 3 key concepts. It's very simple. It has the concept of a volume, which is just a namespace that is presented as a POSIX mount, uh, and it contains bricks. Bricks are basically the basic unit of storage, and it is represented by an export directory on a server. So typically, it's a file system. Is a brick. That becomes a brick, and then you have server/nodes, which actually, you know contains those bricks. And a volume actually straddles, multiple, servers with the bricks. So this is an example of a distributed volume where you can see, the volume has a single mount point that is on the left, top corner, and it is straddling, 2 servers, each of which has 1 brick each. And this is a distributed volume, which means that there are only, it's not a replicated volume, which means that there is only 1 copy of 1 file. So if server 2 went down, you wouldn't have access to file 3. You would only have access to file 1 and file 2. Here's the stack inside Red Hat storage nodes. The part in blue is basically Linux, RHEL. There's no changes there. We have some tuning guidelines on how to create bricks on RHEL, but that's about it. The part in red is where, all of the Gluster magic is, the translators and everything. But you'll see how we leverage, pretty much everything from RHEL. So the storage stack underlying in the file system is pretty much RHEL. And on top of that, we lay the translators that are necessary for Gluster to do the file serving. In Gluster, the daemons like NFS, SMB, etc., they all run inside of the Gluster node. So requests, incoming requests end up inside the node. The next slide is just an example of a distributed replicated volume. A distributed replicated volume is, as I showed, it's just like a distributed volume, but in this case, it's replicated too. So you have server 1 and server 2 forming the two legs of a mirror, server 3 and server 4 forming the two legs of a mirror. So files that are going to server 1 are replicated to server 2, and files that are going to server 3 are replicated on server 4. So how does Gluster actually, actually spread out all these files amongst this bricks? So what Gluster uses is called the hashing algorithm. The way it works is when an application creates a directory within the RHS volume, each directory is assigned a 32-bit hash range for every brick. So in this case, you see data app 1 is a directory, and it has been assigned, 0 to 1 billion, in brick 1, 1 billion to 2 billion in brick 2, 2 to 3 billion in brick 3, and so on and so forth. And so the hashing algorithm, when a file is written to the directory, what Gluster does, it simply runs the hashing algorithm on the name of the file, and that gives it a number, and generates a number, and then it looks at the number and looks at the directory under which the file is to be placed, and then looks up, in which brick is that hash range. So the directory, even though it's one directory across the entire volume, the different bricks that make up the volume has different hash ranges. So in this case, you can see info.text. If you run the hash algorithm, it comes up as 1323. It's a number between 1 billion and 2 billion. So it got placed in storage node or brick 2, as opposed to brick 1, 3, or 4, because that was how the hash range was laid out. And if you go to the next slide, you will see as new files are created, each of them is hashed using the Gluster hashing translator. So if you look at stuff123.txt, if you see and run the hash algorithm, the first one is, between 0 to 1 billion, so it goes on the first storage node. The second one is between 3 to 4 billion, so it goes into the third storage node. And the third one actually is, sorry, it's just the second one is, goes to the third storage node because it is between 3 and 4 billion, and so on and so forth. I think, yeah, it's not matching up. But that's how it is, based on what the hash is, you get placed under the proper hash range, and the algorithm that's used for hashing is known as the Davis-Meyers algorithm. Here's the next slide that talks about how the data actually flows in RHS with native client in native clients. Basically, it's for the native client, it's only a two-step process, because the native client inherently knows which brick has what file, so it goes directly to the brick. So it's 1 and 2. However, using the hash ranges, etc. So every, when you place a file in Gluster, you do a calculation to determine what the brick is. When you have to retrieve the file, you do the reverse calculation to get it. So there is no metadata server in Gluster land. Gluster has a lot of metadata, but that's stored in the extended attributes of file systems. There are no external metadata servers that one need to configure and one need to distribute and one needs to manage for that. So that's pretty cool with Gluster. Then this slide shows how it works, how Gluster works when NFS or SMB is used. Now with NFS and SMB, you don't get the full impact of the Gluster native client. However, you get it inside of the storage cluster. An NFS or SMB request first ends up going to, the storage cluster, and from then on, it follows the native client-like access. So that both NFS and SMB on its backend has a native client integration, so as to speak, conceptually, so that it knows exactly in which brick a file is. And so if you see, the first request, goes to IP load balancer plus HA. The second request goes to brick 4. the third request now goes to fetching the file, and the fourth request is a response. This is actually a write going on. So the three is writing, fourth is a response, and five is back. So so the way to look at it is, with NFS and SMB, you have one hop extra going into the storage cluster. From inside of the storage cluster, it goes like native client. So this slide just basically shows how replication actually works inside of cluster. So this phase, these steps are often referred to as a five-phase commit. You take a lock on the clients that want to write a file. Takes a lock on both the nodes. Then they do a pre-op on the extended attributes of the file. Usually that amounts to incrementing the extended attributes. Then you do the actual write, which is the operation. Then you decrement the extended attributes, which is called a post-op, and then you unlock the file. So that's the process. But however, this is not exactly followed in this way for every situation. For example, we have some optimizations for VMs where the lock is not held, or for sequential files, we call it, I forget the name of the feature, but exactly, but we basically hold, don't let the lock go. We don't unlock. We keep the lock in so that we can kind of piggyback on it's an optimistic lock that we hold so that we don't have to unlock and relock. So this, there's some other optimizations that are there which you can turn on and off, uh, based on your workload, and these are usually set in the profiles. So let's go to quickly look at GlusterFS upstream innovation pipeline. This is basically the upstream roadmap for GlusterFS, which becomes downstream in the product, just like every other product in Red Hat. So we released GlusterFS 3.5, GA. It went GA in May of 2014. The big things there were distributed georep, scalable quotas, read-dir ahead, file snapshots for virtual machines, libgf API support for NFS, Ganesha, brick failure detection. GlusterFS 3.6, which is supposed to release in August of 2014, is supposed to include volume snapshots, AFR v2, data classification, erasure coding. We're looking at erasure coding, but we might not make it, a few things like that. But it's ongoing now. Work on that is ongoing now. Further going ahead into 3.7, which is later this year, maybe the end of this year. We're looking at multiple things like more scalable cluster nodes, scalability for big data, content cloud enhancements, improvements for OpenStack, data protection, georeplicated snapshots, bitrot detection, all that stuff. So this one will gel a little bit more in July-August timeframe, when we actually enter into the planning phase for Cluster 3.7. Today, we are still not in the planning phase. So let's look at what we are doing downstream, which is actually the product update, to include all of these, improvements that are happening upstream. What we're doing, what are the upcoming, next 6 to 9's product plans. So before we go into the next 6 to 9's, we just want to look back. Looking back, Red Hat Storage 2.0 was actually launched in June of 2012 at Red Hat Summit. So there are 6 numbered updates released. We added use cases like virtual machine image store for Rev. We also did a lot of work on performance and stability and improving the performance and stability of the solution. It's going to end of life by the end of this month. We have only very few customers using it. Most of them have actually migrated to 2.1, which is good. Red Hat Storage 2.1 was launched in September of 2013. We have so far only 2 numbered updates for this. We have added Coda, georep, high performance georep, management console, and SMB 2.0 support in the various updates, including the GA. It is the current shipping release. So this was a little bit looking back on what we have done so far. Now let's look at what's going on for the next 6 to 8 months. Our next big release, that's coming up in midsummer of this year, hoping July is where we are targeting is called Denali. It's Red Hat Storage 3.0, so the next, basically the next major upgrade in terms of version number. It will be based on RHEL 6, not RHEL 7 yet, and GlusterFS 3.6. A big feature on this is volume snapshots with the user serviceability. We'll also introduce monitoring of Gluster using Nagios. So this has been a complaint or sticking point for us for a while, where Gluster could not really be monitored unless you looked into the log files. We are introducing the Hadoop plugin, by which you can run big data workloads on Red Hat storage. We are going to support up to 60 drives per server, up from 36. We support up to 36 drives per today, but it's going to up to that, up to 60, which means with the big new servers and six terabyte disks, you can actually have a 1 petabyte cluster if it's not replicated with just 3 nodes. That's pretty huge. We're going to support non-disruptive upgrade from previous major version, and we are supporting catalog ID based logging to make people's life easier with with regards to supportability and diagnostics. Everglades will be our next release. We're looking at next year, early next year, for the release of that. It's really tentative on what we do in Everglades yet, so I will not be spending too much time on that today. So I'll zoom in instead on Denali, which is the thing, that's the hot new release basically. Just a second. So Denali, is the official version is Red Hat Storage Server 3. Theme is data protection and storage management and monitoring based on GlusterFS 3.6. Denali is actually going to release on RHEL 6 mainline, no longer in US. People who are familiar with Red Hat storage might know that we used to release our product in US, no longer. The underlying file system will still be XFS. Underlying volume management will be via DMThinP. And the entitlement system that we will use is CDN and subscription manager. So we are moving away from RHN. As you know, RHN is getting sunset or is being discouraged to be used for most new Red Hat products going forward. So we are kind of adopting CDN, and not just because RHN is being discouraged for use, but all new products in Red Hat, including RHEL 7, RHEL OSP, others have started to use this CDN, and in order to work well with them, we thought it was a must-have to kind of go to CDN. So the big feature in Red Hat Storage Server 3.0 are snapshots. Snapshots are Gluster volume snapshots. It's a point-in-time copy of a GlusterFS volume. We'll provide the capability to create list status, info, restore, and delete snapshots. We'll support a maximum of 256 snapshots per volume, which seems to be the de facto industry standard. Right now, a snapshot can be taken on only one volume at a time. In future, we plan to expand that so that people can group one or more than one volume together and snap them together. Snapshot names need to be cluster-wide unique. In this release, we'll be able to manage snapshots using the CLI only. So the GUI or the UI part of that will be coming later. And for user serviceable snapshots, it is in scope, but may need some more time to stabilize. Somebody started their video. I don't know who is that. That's okay. Scope of monitoring. We are monitoring Red Hat Storage Server logical entities like cluster, volume, brick, and node. We're monitoring the physical entities, CPU, disk, network. We are alerting when critical components fail using SNMP and SMTP. We're reporting historical, record of outage events, notifications. So whatever you expect from a more or less comprehensive monitoring system will be there, and it's all being modeled and leveraged and delivered using Nagios. So the system model for Red Hat storage, or these entities are being modeled after Nagios services and Nagios hosts and Nagios host groups. So if you're familiar with Nagios, Nagios lets you kind of model your services and entities using their own modeling, which is cool, but it is also not the most flexible. But if you want to use Nagios, you kind of have to use their modeling, and it usually gives you three kinds of states for every entity, whether it's green, yellow, or red. It's either okay or warning or critical. So that's kind of what we'll do in this release. The use cases that we are supporting for Nagios include, um, basically use case one where user has no existing monitoring infrastructure in place or does not use Nagios. User already has Nagios infrastructure in place, so they can use the plugins only. This is very common in the field. And the third use case is people will be, end users will be able to use Nagios in conjunction with Red Hat Storage Console. So all these three are being considered. In addition, we are looking at a new kind of way, for delivering Red Hat storage. People who are familiar with Red Hat storage will know that we currently deliver Red Hat storage using what using an ISO. So it's an ISO based approach. You have to get an ISO, install it, and that converts a server into a storage server. We are thinking and working on it in the BU to actually come up with a slightly different kind of packaging model based on what Red Hat or RHEL does with add-ons, where you'll be able to only take the RPMs that belong to Red Hat storage and layer them on top of RHEL, as opposed to trying to consume the entire ISO. The reason we have been thinking about it, or we are planning to do this, is because we want to comply with corporate governance and security requirements. This is probably our requirement number one. We have received a lot of feedback from the RHEL install base saying that it would be great if they could just take the RPMs and layer it on top of their existing RHEL servers, as opposed to trying to consume a whole new product that has to go through their verification and security, sanity checks and everything else, and a new build has to be generated. They didn't want to really do that. So that's number one motivation. We also think by doing this, we will be able to support co-resident applications better. So if you have co-resident applications, then you don't have to necessarily port them to Red Hat storage server. You can actually run them where they are and instead layer the RPMs on top of in that environment. Bring the RPMs. That makes lives easier. Embedded use cases particularly are also going to be big beneficiaries, because embedded use cases today, they just build their own environment from scratch, and they take a whole bunch of third-party tools and their homegrown apps, etc., and cook them together. So asking them to do the same inside of a Red Hat storage server environment seems like a lot. Instead, they would like to have the RPMs and do the same. Like, it's just for them, it's a third-party, storage app that they would like to bring into their environment. And this is also adds to the ease of usage for channels and partners, because they can simply take RHEL servers and convert them into storage servers, make it easy for them. So this is just a graphic of how it will look, or how it looks today on the left, which is an Red Hat storage ISO, and how it will look is tomorrow is on the right, which is RHS as an add-on on top of RHEL. So we won't be discontinuing the ISO model. It's it is going to stay. The add-on actually is misplaced a little bit. It should go under the right and top, but so it's a bit confusing, this picture. I don't know how that happened, but basically we are not going to take away the ISO model. It's still going to be there. And there's a lot of people really like it because it bundles every entitlement that you can think of is needed, and gives it to you in one clean package. And people don't have to go hunt for the RHEL entitlements or JBoss entitlements for running the console. So we're going to keep it, but in addition, we want to introduce this option. The timing of this option, we want to do it, you know, about Denali release time frame, but we may or may not be able to do it exactly on the same day as Denali GAs, because we just have to make sure that Denali GAs and this can be offered as soon as possible after GA. We want to keep the GA date ready, pretty clear of any other kinds of dependencies. So zooming into Everglades, I talked a little bit about Everglades before. We are looking at formally supporting three-way replication. We will try to support SSDs now as bricks and as a tier. We're using DM cache. We're looking at enhancing the existing snapshot capabilities by introducing consistency groups and then snapshot scheduling, which we don't do today. You'll have to run a cron job to schedule snapshots. And then, support for RAID-less hardware configurations. This is something that has come to us a lot. We have NFS V4 today basically in tech preview mode. We want to bring that into full support. And there are a few other things that we are exploring right now, which includes bit rot detection and restoration, erasure coding, using a new translator called the dispersed translator, which was contributed upstream. We're looking at multi-protocol support for NFS and SMB, again with NFS Ganesha and NFS V4. So people will be able to access, files using NFS and SMB at the same time. And we are also looking at PNFS server-side support, but these are all tentative, very, very tentative today. We'll have a much firmer roadmap, with committed, deliverables in a couple of months from now. So the last section is, what's up with big data storage? Um, there's, basically what we have done with big data is we have tried to make sure Red Hat Storage is a good storage platform for running Hadoop MapReduce workloads. And our tagline or our value prop is not about replacing HDFS, just so that you know. We talk about bringing, running in place analytics, which means bringing your Hadoop to the data as opposed to taking your data to Hadoop. That has been our marketing tagline for a while. Basically, what it means is, if you have data that you already have inside of a Red Hat storage volume, you should be able to simply run your analytics on top of it instead of copying it back and forth between Hadoop clusters, having all the overhead of preparing the data for putting it into HDFS, running your analytics on it, getting the results, and then moving that data back to where you want it to be, permanently. So that's been our biggest thing with Hadoop. We haven't really tried to go out and say in the market that, hey, I've got a new file system alternative for HDFS, because we don't compare with HDFS in terms of scalability yet. And we also don't compare in terms of some of the other things it does, in terms of basically scalability, really large size clusters, and that's kind of where we are. So, however, we do a few things that HDFS doesn't do, which includes, NFS and FUSE support for data ingestion. There is no single point of failure. We are POSIX compliant, co-location of compute and data. This is similar to HDFS, but it's a plus for us against traditional storage solutions where this is not allowed. We will support multiple volume with Denali, so ability to partition data across multiple namespaces and running analytics on top of them in parallelly, which nobody else can do. And we have DR capabilities built into Red Hat Storage. So, if you wish to move your data to another site, after you have run your analytics, you can do that, and that's doable today because we have asynchronous geo application built in. So the Hadoop roadmap, plugin roadmap, we have high touch beta that we released in October, which was kind of constrained to a single volume in a cluster with one brick per server. It supported HTTP 2.0.6 and its 8 services. We want to promote that Hadoop plugin to GA status so anybody can use it. It's no longer a high touch beta candidate, so only a very few people. We are not hand holding people. We'll be able to run in-place analytics on existing data in Red Hat Storage server volumes. And we plan to support Hadoop Distro 2.1 and some of its new services, but currently it's looking like we'll still be stuck with 206 initially. This is Hortonworks 206. We are only partnered with Hortonworks, not with Cloudera or MapR. So when I refer to HDP, that's what it refers to, because we are not a distro vendor. Red Hat does not produce a commercial distro for Hadoop. So we are partnering very actively with Hortonworks so that Red Hat storage works really well underneath Hortonworks. So that's kind of where I am. So let's do a quick demo for Hadoop server, basically. And there's some questions. Um, I think I hope. Okay. Okay. Let's quickly do a demo of the upcoming feature. Uh,
Okay, so we are here to present you a demo cluster volume snapshots. What we are going to cover is how do we create a cluster volume? What we are going to cover is how do we.
So in this demo, it's a long demo, so I don't have enough time, to run the entire demo. So what we plan to do is we basically give you a snapshot of the different, not a snapshot, but a glimpse of the different operations. And this is what we'll do. We'll create a new cluster volume. We'll create a snapshot for that. We will list that snapshot. We'll create another, we'll take another snapshot of the same volume, create some more files. Actually, we'll first create a cluster volume. We will create some files. We'll take a snapshot. Then we'll list the snapshot. Then we will, create some more files inside the same cluster volume, then take another snapshot. And then we'll restore to the first snapshot and show you that it has only the files that were created, the first time over. So I'm going to skip some of the initial grunt work, that is being shown on how a volume is getting created, etc., and jump right on where the volume has actually been created, and we are going to take a snapshot.
Volume is started. So we have a volume called vol0, which is distributed replicate. Number of bricks 4 is a 2x2 distributed replicate volume. We'll mount this volume to a client. Here is the client. We will fuse mount the volume that we just created. Okay, so the volume is mounted. Let me get into the volume. I'll create some files to the volume that we just created.
Andrew, can you hear me? We seem to have lost connectivity, or something is happening. Okay. We've only got 5 minutes left, and I think we lost
5 files.
No. I think
volume vol0.
Can you hear me now?
Names are file.1 to file.5.
Yes, I can hear you, but the video is sort of like it's in a circle for some reason. So I don't think playing a video over the blue jeans is a good idea, because this, from a bandwidth perspective, is a bit of an issue.
Okay, so what I'll do is I'll stop the video.
Yeah.
And I can take some questions now, because the video is just going through a whole bunch of commands and.
So Andrew just posted a link to the video so people can watch it at their own leisure. And the question that is coming repeatedly up from Korea is, can we now sell Red Hat storage in Korea?
Yes, I think it can be sold now. From what I understand, it has been opened up in Korea, and I will be in Korea on next week on Monday, meeting the sales team and seeing a couple of customers. So if you guys have questions and on use cases, etc., please have them ready. I'll be in that office.
All right. I think we have to wrap up here to give also the other presenter a chance to set up and everything. But thank you very much for your presentation. And slides will be shared after the event. The recording will be shared. And if there's any other questions, they can certainly also reach out to the presenter directly. You should have their names anyway. So thank you so much.